Hi, today we are on the chapter of complex number. We will be doing two questions. Let's start off with question number 1. If 2z1 over 3z2 is purely imaginary, find the value of the modulus of this expression. Now, what do you mean by imaginary? A complex number consists of two parts, a real part and an imaginary part. Now, if the real part is 0, then we say that the complex number is purely imaginary. Give you an example. If z is equals to a plus bi. Now, if a is equals to 0, then z will only be left with the imaginary part. Then we call that z is purely imaginary. Okay, let's start the question now. Now we are given this 2z1 over 3z2 is purely imaginary. Now if this is purely imaginary, that means I can write it in the form of equals to ki. Now, and then we are asked to find the modulus of this expression, modulus of z1 minus modulus of z2 over modulus of z1 plus modulus of z2. Now look here, we are given that this expression is z1 over z2. So what we can do is we divide the numerator by z2 and denominator also by z2. And that becomes modulus of z1 over z2 minus 1 over z1 over z2 minus plus 1, and then the whole thing I have to mod it. Okay, but z1 over z2 is 3 over 2 ki. Alright, so this will be equals to 3 over 2 ki minus 1 over 3 over 2 ki plus 1. Now we can simplify this expression. This becomes modulus of 3 ki minus 2 over 3 ki plus 2. Now, perhaps we can just rearrange this. Alright, what do we get? Now we are more familiar with the real part being in front, so it will be equal to minus 2 plus 3 ki over 2 plus 3 ki. Now, we can take out the minus 1 for the numerator, so this will be equals to 2 minus 3 ki over the modulus of 2 plus 3 ki. Now, why is this so? Now, you realize that because z is equals to minus, now the modulus of this z will be equals to the modulus of minus z. Alright, so I just remove the minus, alright, or times minus 1 to the numerator. Okay, so I get this. Now, so this is equals to 1. Now, can you all see that? Now, you realize that the numerator is the conjugate of the denominator. So you find that this is equals to what? Now, what is this equals to? This is actually equals to z over conjugate of z. Alright? And then I modulus each of them. Now this is equals to 1 because z modulus of z will be equals to the modulus of its conjugate, all right? Right, so this divided by this, so you get 1. Okay? Question 2, if z is equals to x plus yi and w is given by this expression, then show that z is purely real if modulus of w is equals to 1. Now let me write down what is given to us first. So you have z is equals to x plus yi. W is equals to 1 minus iz over z minus I, and then we have modulus of w is equals to 1. Now we are supposed to show that z is purely real. That means x must be equals to, no, y must be equals to 0 if it is purely real. That means z will just be the real part of it, all right? That is x. Now, so we have w, mod of w equals to 1, all right? So mod of w squared will be equals to 1, and then that will be equals to 1 minus iz over z minus I times modulus of the whole thing here, 1 minus iz over the modulus of the whole thing, of the denominator. Now, this part will be equals to what? Will be equals to 1 minus iz times, now you can modulus each of them separately will be the equals to the modulus of the whole thing. So modulus of 1 is 1, modulus of iz, now modulus of I first, modulus of I become minus I, all right? So you plus, you times them, you will be I, then it will be z, okay? Now the denominator here will be z minus I, here will be modulus of z plus I, okay? Now this is equals to 1, so we can do a cross multiply. So you get z minus I into modulus, conjugate of z plus I into 1 minus I z times 1 plus I conjugate of z. Alright, so you multiply out, then you will get z conjugate, now plus iz minus I z conjugate, now then this will be plus 1. Then this will be 1 plus I conjugate of z minus I z plus z times z conjugate. Now these two is the same, and these two is the same. So we cancel out each other. Now, okay, these two I can move over, and this one move over. Now these two are like terms, and these two are like terms. Alright, so you have 2iz equals to 2iz conjugate. So z is equals to z conjugate. That means implies that z is real. Now for this to be true, your imaginary part must be 0. Alright, so implies that z is real. In the next video, we will be working out these two questions. I will be putting the URL link in the description below. Thank you for watching. Have a nice day.